Alright guys, today we are going to talk a little bit more about parabolas, about quadratic functions, quadratic equations. We'll talk about how to solve quadratic equations by graphing. One thing that I want to point out, many of you did a really nice job on yesterday's homework, and the only thing I want you to remember, the only thing that I could point out in many of the assignments is if parabola looks like this, so if you have a sad face, that is when a is negative. So that means that the number with the highest exponent, with x squared, will be negative. If a parabola is a smiley face, that means that a is positive. And then again, I'm just saying that with regards to yesterday's homework. So now, if we think about the solutions for the quadratic equations, if you look at those three examples, they are different. This one crosses this parabola, crosses x-axis twice, and that means that it has two unique real solutions. This parabola crosses x-axis once. Well, it doesn't really cross. What happens is it gets to x-axis and then it bounces back. So this has one unique real solution. And if the parabola does not cross the x-axis, that means that it does not have a real solution. Now, we want to solve this equation by graphing, so I want you to see what we are doing. We have our equation and we are making it equal to 0, so we want to see how this parabola is going to look like and where is it going to cross the x-axis. We are going to use the same technique we did yesterday to graph. So the first thing is we are going to figure out what the vertex is. And to find the vertex, we'll find the axis of symmetry first. I'll remind you the formula x is equal to negative b over 2a. Well, and I should have listed what a, b, and c is. So a is 1, b is negative 2, and c is negative 8. Now, in what I just said, let's keep in mind the a is positive because it's positive 1. So I know that my parabola is going to have a smiley face. Okay, it's going to be open up. Let's find what the axis of symmetry is. Negative is in the formula, b is negative 2. We'll clean this up in a second. And then we have 2 times 1. Negative, negative gives me positive. 2 divided by 2, the answer is 1. So I know that the x-coordinate of the vertex is 1. And to figure out what the y-coordinate of the vertex is, what I am going to do with this one is I'm going to plug it everywhere in place of x. So I will have 1 squared minus 2 times 1 minus 8. Let's make sure we follow the order of operations. 1 squared is 1, 1 minus 2 minus 8. 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. So I know that my vertex is at 1 and negative 9. I would very strongly suggest to do something that I haven't done yet. We found that the axis of symmetry was at 1. You should put it right on the graph. And then we did get that the y-coordinate of this vertex was negative 9. So now we can say, okay, it's at 1 and negative 9 is right in here. I do know what the y-intercept is. The y-intercept is equivalent to whatever c is, and that is equivalent to negative 8. So you can put that point right on the graph. And then you can use the symmetry and put the other one. And now, I don't know if you remember, because we had talked about this earlier when we started graphing the parabolas. There's really not a slope when you graph the quadratic functions because it's not a linear change. But the change, as long as the a is equal to 1, will follow this way. 1, 3, 5. And what I mean by this is when you go from the vertex, and again, this is as long as this number is 1. If it's different, then we would have to multiply those by whatever a is. The pattern is that the first change is 1 over 1. The next change is 3 over 1. The next change is 1, 2, 3, 4, 5 over 1. And then again, we can use the symmetry. So my next point would be in here, and then my next point would be in here. And look at this beautiful parabola. Again, we need to remember what we were looking for. I will go back to that pattern in a second. We were looking for the solution, so we were looking for where the parabola crosses the x-axis. So I would know that x is equivalent to -2, or x is equivalent to 4. Now, if you did not remember this pattern, you have to kind of try to figure it out. So, we could plug in the numbers into our function and see, or our equation, and see what would happen if x is equal to, well, and I know what the answer is, so I want to see if I am right. What happens when x is equal to 4? So if you plug in 4 everywhere in place of x, you will get 4 squared minus 2 times 4 minus 8. We have to figure out the exponent first, so that's 16. 16 minus 8 minus 8. Look at that, that is equivalent to 0. So when x is equal to 4, y value is equal to 0. So we were able to show that this is going to be our solution, or one of them. We can now test and check what would happen if we plug in x is equal to -2. Everywhere in place of x, I am going to put in -2 minus 8. -2 squared is 4 plus 4 minus 8. 4 plus 4 is 8 minus 8. Look at this, we got this one correctly as well. So 2 ways, please remember this pattern for the quadratics. We will talk about this pattern a little bit more, but it's something that is really, really good to remember. Again, there's no linear change when we talk about the quadratics. There's a different pattern that we need to follow. All right, let's take a look at example number 2. And example number 2 is going to have one root, so we know what we are looking for. We are still going to start the same way. We are going to figure out what the vertex is. And we know that in order to find the vertex, we'll start with the axis of symmetry. I hope by now everybody remembers that the formula for the x-coordinate for the axis of symmetry is -b over 2a. And again, I did not do this well. I want to list a, b, and c, but there's something weird going on here. So notice how this equation is not equal to 0. We need to clean it up. And to clean it up, I am going to move this 9 on the other side. And I will make sure I will put it in a proper order. So I am going to have x squared minus 6x plus 9 is equivalent to 0. So now this is an equation I can easily work with. And then I know that my a is equal to 1, my b is equal to -6, and my c is equal to 9. All right, let's figure out the axis of symmetry. -b, -6, divided by 2 times a, and a is 1. Negative, always remember that gives you +6. 6 divided by 2 is 3. And do remember, this is going to be your x-coordinate of the vertex. And I am going to draw the axis of symmetry right away on my coordinate plane. Okay, now think about this for a second. What are we going to do next? We are going to find the vertex, but we are going to keep this in mind. This is positive, it's 1. I know that my parabola needs to look like this. It's open up, it's a happy face. Well, let's see what is going to happen if I plug in 3 into my equation. You can use either this one or this one. It doesn't really matter. I'm going to use this one. So 3 squared minus 6 times 3 plus 9. 3 squared is 9. 6 times 3 is 18 plus 9. 9 minus 18 is negative 9 plus 9 is 0. Look at this. So my vertex is at 0.30. So my vertex is right in here. Now, I know that the parabola is going to be open up. I can easily find the y-intercept. Think about this for a second. What is the y-intercept equal to? I hope you get it. Y-intercept is c. So if you think about this, what would happen if you plug in 0 for x everywhere? And that is equivalent to 9. So it's right in here. Now you can think about this and you can see if our pattern works. I will write this right in here, our change. 1, 3, 5. We will talk about this pattern more. So the next one would be, and again, this works because it's 1. So 1 up, 1 over, and then 3 up, 1 over, and then 1, 2, 3, 4, 5 up, 1 over. Notice how this point is symmetric to this point, so it looks good. This point is symmetric with this point. This point is symmetric here. Look at this beautiful parabola. And the most important thing we need to remember what were we looking for? We were looking for the solution, and we are reading our solution from the graph. X is equal to 3. And this is one unique real solution. I will go over 2 more examples, and then you will have some assignment for you to try by yourself. So notice this is going to be no real roots. I have my A, B, and C. Well, I am going to list them first this time. A is equal to 2, B is equal to negative 3, and C is equal to 5. I am going to start with finding axis of symmetry. Because this is going to allow me to find the vertex. Again, I hope you remember the formula by now. X is equal to negative b over 2a. Negative 3 over 2 times 2. I see we are going to be working with really nice fractions. So 3 over 2, not 3 over 2, 3 over 4. 3 over 4 is the axis of symmetry. And not only it is an axis of symmetry, it is going to be the x-coordinate of the vertex. I know that it is somewhere here, more than a half, less than 1. Here's the axis of symmetry. All right, let's take 3/4. Let's plug it in everywhere in place of x. I'm thinking maybe it would be a good idea to write this as a decimal and use a calculator, but I am not going to do this because I don't respect decimals that much. I like fractions. Again, we have to make sure we square first, so that is going to give me 9 over 16 minus 9 over 4 plus 5. I am going to multiply this. 2 times 9 is 18, 18 over 16. Because I know I need to combine those two, I am going to make this as a common denominator. So I need to multiply this by 4 and this by 4. So that is going to give me 36 over 16. And then I'm going to be adding 5. Let's see, 18, I am right here, and then multiplied by 4, so it looks good. 18 minus 36 is negative 18 over 16 plus 5. Well, I'm going to write this as an improper fraction, and that is negative 1 and 2/16, which is 1/8. And then I want to add 5. So, well, again, a quick review from fractions. I have a negative number, positive is bigger, so my answer is going to be positive. I can take 5 and subtract 1, that would be 4. And then I still have to subtract an 8, so it is going to be 3 and 7/8. So my vertex is at 3/4, and the y-coordinate is going to be at 3 and 7/8. So this is my axis of symmetry at 3/4, and then I am going to go 1, 2, 3, and a little bit, 7/8, somewhere here. All right, now we didn't talk about this yet, but notice this is positive. I know that my parabola needs to be open up. So I know it is going to go here, which means it is never going to cross the x-axis. Well, I do know what the y-intercept is. The y-intercept is at 5, so I can put this point here. Using symmetry, it's going to be somewhere here. The parabola is going to go up. I'm not going to be crazy about being very particular about this one, because the question is to solve it, and knowing that the parabola is open up, knowing where the vertex is, it is clear that this one has no solution, because it is never going to cross the x-axis. All right, and then we have the last one. And the last one is very interesting. We are going to use the estimations. X squared plus 6x plus 6. Again, axis of symmetry. X is equal to negative b over 2a. Well, my a is 1, my b is 6, and my c is also 6. Negative b over 2. Well, now at least we are getting a nice number. I know that the x-coordinate of the vertex is negative 3. And I also know that that is going to be my axis of symmetry, my line of symmetry. So let's take negative 3, plug it back into the equation. Negative 3 squared, that's 9, minus 18, plus 6. That's negative 9. Negative 9 plus 6 is negative 3. So look at this. My vertex is at negative 3 and negative 3, so it's right here. Now let's look at the y-intercept, because that's always easy to find. I hope you remember by now that the y-intercept is whatever the c is, and that is equal to 6. It always needs to make sense. So let's check. We didn't talk about this, but how is this parabola going to look like? Because a is positive, it's going to be open up. Think about this. Well, it does make sense, right? So 3 away, 1, 2, 3. I am using the properties of symmetry. Because a is equal to 1, I can follow my 1, 3, 5 pattern. So 1 up, 1 over. Let's see if I am going to get to this point. And then 1, 2, 3 up, 1 over. 1, 2, 3. Oh, 1, 3, 1, 2, 3, 4, 5. You know what happened is I put this point a little bit too low. I put it at 5 and I was supposed to put it at 6. So notice how I made a mistake, but then I follow the pattern and I noticed that I'm getting old and blind and I just put it in my y-intercept in the wrong place. Well, it's fixed now. It should be at 6, and then it follows my 1, 3, 5 pattern. 1, 2, 3 up, 1 over, 1, 2, 3, 4, 5, and 1 over. Again, it was my silly mistake of putting the y-intercept in the wrong place, but it works. Now, again, we need to remember that we are answering the question. And our question is, where is our x-intercept? Notice, I know where this point is. When x is equal to negative 2, y is equal to negative 2. When x is equal to 3, I am already above. So what it means is that my solution is going to be between -1 and -2, right? Because it's somewhere here. And then there's another one that is between -4 and -5. All right, make sure you try to make this picture pretty, and then you are looking at where your parabola is going to cross the x-axis. That is going to be your solution. Your assignment is to complete everything else on this handout. There's a good amount of questions. Please make sure you follow the same structure. You will have examples that have 1 solution, 2 solutions, no solutions. You will also have examples where you will have to estimate, like in example 4. Again, follow the ones that I am giving you, and there are also some word problems. If you need help, come see me during my office hours tomorrow. Otherwise, if not, if you don't need any help, make sure you are very careful with simple operations. All right, have a great day, guys.